Hello friends, today in this video I am going to discuss inverse Laplace transform. So already in my last videos I have discussed about the Laplace transform. Here in this video I am going to discuss inverse Laplace transform. So the definition of inverse Laplace transform is if L of f of t is equal to f of s. If L of f of t is equal to f of s, then f of t is called as inverse Laplace transform of f of x, and it can be denoted as, and it can be denoted as, f of t is equal to L inverse of f of s. So simply I will tell you, this is the Laplace transform, that is L of f of t is equal to f of s. Take this Laplace to RHS, it becomes inverse, that is f of t is equal to L inverse of f of s. Here we are going to find inverse Laplace transform by, at the beginning we are using the standard formulas. After that we can find inverse Laplace by partial fraction method as well as inverse Laplace by convolution theorem. So first I will discuss the formulas one by one, then I will go for the example. So one by one formula. The first formula is, we know that Laplace of e raised to at, Laplace of e raised to at is equal to 1 upon s minus a. So this is the Laplace of e to the power of a. So I will write here inverse of this one, L inverse of 1 upon s minus a is equal to e to the power of a. So take this L Laplace to RHS. So therefore L inverse of 1 upon s minus a is equal to e to the power of a. So second formula, L of e to the power of minus at is equal to 1 upon s plus a. So it implies L inverse of 1 upon s plus a is equal to e to the power of minus 8. So third formula, we know that L of, that is Laplace of psi at is equal to a upon s square plus a square. So L inverse of a upon s square plus a square is equal to sine of a. So while solving the example, what I do, I will take this a to RHS because as it is constant term. So this implies L inverse of 1 upon s square plus a square is equal to 1 upon a into sine of a. So next one, Laplace of cos at is equal to s upon s square plus a square. So therefore L inverse of s upon s square plus a square is equal to cos of a. So here you cannot transfer this s to RHS as it is parameter. So next formula is Laplace of sin hyperbolic of a into t is equal to a upon s square minus a square. Therefore L inverse of a upon s square minus a square is equal to sin hyperbolic of e. Sin hyperbolic of et. So while solving the example, again I will shift this to RHS. It becomes L inverse of 1 upon s square minus a square is equal to 1 upon a sin hyperbolic of. So these are the some formulas. The next formula is L of cos hyperbolic of at is equal to s upon s square minus a square. Therefore L inverse of s upon s square minus a square is equal to cos hyperbolic of a into t. So next formula, we know that L of t raised to n is equal to n factorial upon s to the power of n plus 1. So therefore n inverse of n factorial upon s to the power n plus 1 is equal to t to the power of n. So here this n factorial is constant. Therefore I will take L1 to RHS. This becomes n inverse of 1 upon s to n plus 1 is equal to t raised to n upon n factorial. So while solving the example, what I do here, on both sides I will put n equal to n minus 1. I will simplify this formula. For that, n inverse of 1 upon s raised to n is replaced by n minus 1. Minus 1 and plus 1 get cancelled. So the remaining term is n. So here we get t raised to n minus 1 upon n minus 1 factorial. So this is what n inverse of 1 upon s raised to n. This formula is what? When n is positive integer. So similarly, the next formula is L of t raised to n is equal to gamma of n plus 1 upon s to the power n plus 1. So this is for rational numbers, when n is any rational number. So this implies L inverse of gamma of n plus 1 upon s to the power n plus 1 is equal to t raised to n. So here again n plus 1 is what? Constant. So I will write n inverse of 1 upon s raised to n plus 1 is equal to t raised to n upon gamma of n plus 1. While solving the example, so I am not going to use this formula. I will simplify this one. Again I will replace n by n minus 1 on both sides. Therefore n inverse of 1 upon s raised to n. If I replace n equal to n minus 1, so this implies t raised to n minus 1 upon n is replaced by n minus 1. Minus 1 and plus 1 get cancelled. So the remaining is gamma of n. So this is what for integer. Sorry, rest number. Now we will solve some example based on the standard formula. So we take example number 1. Find L inverse of 1 upon S. So here you can observe it is in the form of L inverse of 1 upon S to the power of n. Here n is integer. So we know that L inverse of 1 upon S to n is equal to t raised to n minus 1 upon n minus 1 factorial. So here s n is n minus 2, therefore n inverse of 1 upon s square is equal to t raised to n minus 1. 2 minus 1 is 1, remaining is 2 minus 1 factorial is 1. Sorry, 2 minus 1 is 1, 1 factorial is 1. Therefore, this is what. Similarly, I will take one more example. Second, find L inverse of 1 upon S minus 3. L inverse of 1 upon S minus 3. So, it is in the form of 1 upon S minus A. We know that solution. We know that L inverse of 1 upon S minus A is equal to e to the power of A into T. So we will use this formula. Therefore, L inverse of 1 upon S minus 3 is equal to, by comparing this one with respect to the example, here the value of A is 3. Therefore, this one e to the power of 3 into T. So next, we will take one more example. Find L inverse of 1 upon S square plus 4. So here, it is in the form of 1 upon A square plus A square, that is 2 square. So we know that solution. We know that L inverse of 1 upon S square plus A square is equal to 1 upon A into sine of A. So therefore, L inverse of 1 upon S square plus 2 square is equal to 4 in the, I have written 4 as 2 square. By comparing this one formula with this example, I can see the value of A is 2 here. It becomes 1 upon 2 sine of 2 into T. So next one, find L inverse of S upon S square plus 3. Here I can apply the formula with S upon S square plus A square. Here we have number 3. I will write 3 in terms of perfect square. So we know that L inverse of S upon S square plus A square is equal to cos of A. So I will write 3 in terms of square. So that is L inverse of S upon S square plus root 3 square. Root 3 square is nothing but 3 only. So by comparing with the formula, I can see the value of A is 3. This implies cos of root 3 into 3. find L inverse of 3 plus 2 into S plus S square upon S2. Now we can see this example not in the standard form. So standard form means directly we can apply the formulas. Here directly I cannot apply the formula. For that what I do here, I will simplify this one. Then I will go for the formula. So first, in first step what I do, I will split this one. So solution L inverse of 3 plus 2 into S plus S square upon S cube is equal to, I will split this one, L inverse of 3 upon S cube plus 2s upon S cube, 1s get cancelled, remaining is here 2 upon S square plus S square upon S cube, remaining is 1 upon S. So this implies, so here I will apply linear property and I will apply inverse Laplace to is the term separately. So here 3 is constant, L inverse of remaining is 1 upon S plus here 2 is constant, remaining is L inverse of 1 upon S square plus L inverse of 1 upon S. So this implies 3 into, it is the form of 1 upon S raised to N. So here value of N is 3. So I will apply 1 upon S raised to N formula, that is T raised to N minus 1 upon N minus 1 factorial. So it will become T square upon 2. 3 minus 1 is 2. 3 minus 1 factorial is 2 factorial. 2 factorial value is 2. Plus 2 into, here value of N is 2. So it remains T raised to N minus 1, that is 2 minus 1 is 1. T to the power of 1 is T. 2 minus 1 is 1. 1 factorial is 1. Plus. So here we have L inverse of 1 upon S. We can see L of 1, that is Laplace of 1, we know that is what? 1 upon S. So therefore, L inverse of 1 upon S is equal to 1. It means this is what? 1. So this is the required. So we take some more example here. Find L inverse of S plus 3 upon S square plus 4. So here also this is not in the standard form. Solution L inverse of S plus 3 upon S square plus 4 is equal to, I will split this one, S upon S square plus 4 plus 3 upon S square plus 4. I will write this one as L inverse of S upon S square plus 4 plus 3 upon S square plus 4. So this implies here I will apply inverse Laplace to both the terms separately. L inverse of 1 upon S upon S square. So I will do this for L what? 2 square plus 3 is constant. L inverse of 1 upon S square plus 2 square. So it is the cos formula and this one is the sin formula. So it becomes cos of 2 into t, because L inverse of S upon S square plus S square is cos 80. The value of A is here 2 plus 3 into 1 upon 2. L inverse of 1 upon S square plus S square is 1 upon A into sine of A, that is sine of 2 into t. Take one more example. Find L inverse of s square minus 1 whole square upon s raised to 5. Again, this is not in the standard form. First, I will simplify this one and I will convert this into a standard form. Therefore, L inverse of solution, L inverse of s square minus 1 square upon s raised to 5 is equal to L inverse of. So for the numerator, I will apply a minus b whole square formula. So that is a square means s square whole square minus 2 into ab plus b square, that is 1 upon s raised to 5. So this implies L inverse of. Now let's split this one. S to 4 upon s to 5 is 1 upon s minus 2 into 1 upon s cube plus 1 upon s to 5. So this implies, now I will apply inverse Laplace to all the terms separately. L inverse of 1 upon s, here 2 is constant. L inverse of 1 upon s cube plus L inverse of 1 upon s to the power of 5. So now all the terms in the standard form. So L inverse of 1 upon s is 1 minus 2 into 1 upon, this is what, t square upon 2 factorial plus t raised to 4 upon 4 factorial, because here the value of n is 5, t raised to n minus 1, that is 5 minus 1 is 4 upon 4 factorial. This implies 1 minus n 2 factorial as number 2, this 2 get cancelled, 1 minus t square plus t raised to 4 upon 24. So this is the required answer. Now we take last example on this. Find L inverse of 4s plus 15 upon 16s square minus 25. Solution: L inverse of 4s plus 15 upon 16s square minus 25. First I will split this one. L inverse of 4 into s upon 16s square minus 25 plus L inverse of 15 upon 16 square minus 25. So this implies here 4 is constant. L inverse of s upon 16 square minus 25 plus 15 is constant here. L inverse of 1 upon 16 square minus 25. So here we can observe, here we can apply for the formula L inverse of S upon S square minus S square, that is cos hyperbolic of 18, here sin hyperbolic of 18. The problem with this 16, it should be free from S square. So S square should be free from constant. For that what I will here, I will divide this one denominator by 16. Here also I will divide denominator by 16. So it will become 4. I will take 16 common here and I will write outside the Laplace sign. So L inverse of S upon S square minus 25 upon 16, because here I have taken 16 as common, plus 15. Here also I will take 16 common from the denominator. L inverse of 1 upon S square minus 25 upon 16. So therefore, L inverse of 4s plus 15 upon 16 square minus 25 is equal to, so here it becomes 1 upon 4 because the numerator we are having 4 and denominator 16. So L inverse of S upon S square, and I will write 25 upon 16 in the form of 5 upon 4 whole square, plus 15 upon 16 L inverse of 1 upon S square minus 5 upon 4 square. So now I will apply the formula. We know that L inverse of S upon S square minus S square is sin cos hyperbolic of 18, 1 upon 4. Here the value of A is 5 by 4, that is cos hyperbolic of 5 upon 4 into T, plus 15 upon 16, 15 upon 16. Here is in the form of 1 upon S square minus A square, that is sin hyperbolic of 18 into 1 upon A, 1 upon 5 upon 4 into sin hyperbolic of 4 upon 5 upon 4 into, so this is equal to 1 upon 4. I will write as it is cos hyperbolic of 5 upon 4 into T. 5 on the 5 is the, I will take this one numerator, 4 on the this one. So this becomes 3 upon 4 sin hyperbolic 5 upon 4 into. So in this video we have discussed the definition of inverse Laplace transform. After that we have gone through the formulas of standard formulas of inverse Laplace transform, and based on that formula we have solved some examples. So for more videos you can subscribe my channel, that is Victor Thank you.